Hello and welcome to the part 2 of the Advent of Code 2021, day 8. The description of the problem now is a bit strange and it took me some time to understand it, but I think it's relatively simple to actually implement it. So let's see first of all what we have. We have a file where for every line we have 10 strings with letter between A and G included, then a separator, which is the pipe, and then 4 strings. The first 10 strings represents the numbers between 0 and 9, so all the possible digits that you can have on a 7-segment display, but not in order, which means that one of these values is a 0, another is a 1, another is a 3, and so on, between 0 and 9, but you don't know which one is what. And also they scrambled all the segments, so you don't know, for example, whether the letter B is this vertical segment, this horizontal segment, or what. What you have to do is to reconstruct what are the mappings of the segments, so how the segments were scrambled. And once we do, we have to interpret these 4 digits that are described using the letters to reconstruct which segments are turned on in this case and how and which number they represent. After that, we just decode this number, which is a 4-digit decimal number, and the sum. So let's see how can we reconstruct from these 10 descriptions of the segments which letter corresponds to which actual segment in the display. The first thing we can notice is what we already know from part 1, which is that, for example, the number 7 is the only one that turns on 3 segments. So when we see a sequence of 3 letters, we know that that is for sure the number 7. The same goes for the number 1 because it has exactly 2 segments, and the number 4 and the number 8. They are special because they have an amount of segments which is fixed. So when we see 3 letters, we know that they are the 3 letters that compose the number 7. We do not know in which order, so if we see ABC, we do not know whether A is this segment, this, or this one. But at least we have some extra information, and we know the ABC are these 3 segments. Now, what can we do? Another thing we know is that every digit between 0 and 9 will appear one and only once in the... sorry for the stupid dog, I hate it. I know that only every digit between 0 and 9 will appear exactly once in the sequence. So every segment across these 7 possible segments will be turned on a specific amount of time. Let's say, for example, the top segment, this one. This is turned on the number 7, on the number 2, because 2 has this segment turned on the number 3, on the number 5, on the number 6, 7 we already wrote, 8, 9, and 0. It is really a lot of segments. So 1, 2, 3, 4, 5, 6, 7, 8. This value, this segment, is turned on 8 times. So when we observe the sequence of 10 segments that are in every line of the problem, we know that a segment that appears 8 times could be the upper one. What is the situation with this segment, for example? It's turned on here, 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 and here. Again, 8 times. This is a bummer because if we see a segment that appears 8 times in the sequence of digits, we do not know whether it is this one or this one. What happens with the other values? We can see, for example, that this segment, the one on the bottom left, is turned on here, 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 and here, so 4 times. What about the others? I already did the count on paper, so I'm not going to do it live, because I want to save you some time. But I can see that every segment has its own amount of times. What can we infer from this information? The first thing we can see is that this segment, and also this segment have a unique number of times that they are turned on, which means that in every sequence of the 10 segments, of the 10 digit descriptions, we will have one letter which appears exactly 6 times, another one that appears exactly 4, and another one which appears exactly 9 times. And they correspond exactly to these 3 segments, so we are already able to decode those 3 segments. The problem is with this couple of segments, this and this, and this and this, because we are going to have 2 letters that correspond to these 2 segments that appear 8 times, but we do not know which one is which one. And the same happens with the segment that appears 7 times. But we know that there are a few digits that are special because they have a unique amount of segments. And to clarify, when we want to assign a letter, we will use the same mapping used in the exercise, which is this is A, this is B, this is this is C, this is D, E, F, and G. This is just the same letters that you can find in the problem, which means that we will remap the letters that we have in the patterns list, the list of 10 digits, to the letters that we have in the problem. We will always use the same letters for the same segment. First of all, we want to create a function that we will call calculate mapping, which will get as an input the patterns that we have in our line 10 description of the list of 10 segments that are activated by every representation of a digit, and do the operation that we just described. First of all, we want to count how many times every of the 7 in the list of patterns, because that's one of the ingredients of our our reasoning. So we have a count which is expressed as S for a segment, and S is for every S in the letters A, B, C, D, E, F, G, is the amount of times that this letter appears in the patterns, no matter where. So we say sum of 1 for P in patterns if S, which is the letter we are looking for, in P. So here we are building a dictionary which for every letter will contain the count, which we know is a number that can be 4, 7, 6, or 8 or 9. Then what we have to do is to reconstruct what are the letters that compose the number 4. So we say that for, let's say segments is 4, are what? Are the 4 letters that appear in the only segment that has length 4. So we say segments in 4, they are S for P for P in patterns if length of P is equal to 4. This is a list of only one element, but we want just the first element. So basically we keep the element, not the list of one element, and that's segments in 4. So what we do now is simply we compare these two data structures, the counts, which tells us how many times every letter appears in the 10 digits representations, and the list of the 4 letters that are in segments in 4, and from that we can infer the whole dictionary. So let's create an empty mapping dictionary, which is what we will populate now. Then we go through the counts. So we say that for segment, for letter, let's say, and count in counts.items. So we simply iterate over every letter and every count. We want to consider all the possibilities. So first of all, if the count is 4, we are fine, because we say that the 4, the only segment that appears 4 times is the segment A. So we can just say mapping of letter is E, not A, because that's the only segment in the canonical representation that is used exactly in 4 different digits. Same happens with the segment B, because the segment that appears only 6 times, because that is the the segment B. Then what we do, we have the segment that appears 7 times, and this is a bit. So let's see how to implement it. First of all, we want to create a function that we will call calculate mapping, which will get as an input the patterns that we have in our line. So essentially the 10 description of the list of 10 segments that are activated by every representation of a digit, and do the operation we just described. First of all, we want to count how many times every of the 7 letters appears in the list of patterns, because that's one of the ingredients of our our reasoning. So we have a count, which is expressed as S for a segment, and S is for every S in the letters A, B, C, D, E, F, G, is the amount of times that this letter appears in the patterns, no matter where. So we say sum of 1 for P in patterns if S, which is the letter we are looking for, in P. So here we are building a dictionary which for every letter will contain the count, which we know is a number that can be 4, 7, 6, or 8 or 9. Then what we have to do is to reconstruct what are the letters that compose the number 4. So we say that for, let's say segments is 4, are what? Are the 4 letters that appear in the only segment that has length 4. So we say segments in 4, they are S for P for P in patterns if len of P is equal to 4. This is a list of only one element, but we want just the first element. So basically we keep the element, not the list of one element, and that's segments in 4. So what we do now is simply we compare these two data structures, the counts, which tells us how many times every letter appears in the 10 digits representations, and the list of the 4 letters that are in segments in 4, and from that we can infer the whole dictionary. So let's create an empty mapping dictionary, which is what we will populate now. Then we go through the counts. So we say that for segment, for letter, let's say, and count in counts.items. So we simply iterate over every letter and every count. We want to consider all the possibilities. So first of all, if the count is 4, we are fine, because we say that the 4, the only segment that appears 4 times is the segment A. So we can just say mapping of letter is E, not A, because that's the only segment in the canonical representation that is used exactly in 4 different digits. Same happens with the segment B, because the segment that appears only 6 times, because that is the segment B. Then what we do, we have the segment that appears 7 times, and this is a bit trickier because we want to detect whether this is, because there are 2 possible segments that appear in 7 different digits, and depending if that segment is also in 4 or not, it can be D or G. So we say if letter is in segments in 4, then we are actually dealing with the letter D. Otherwise, we are dealing with another letter, the one that is not in the segment 4, which is G. Exactly the same logic goes for the segment that has count 8. Again, we have two possibilities, which is that if it is in 4, we have C, otherwise A. This is just an application of what we just said. So we are simply combining the two information to calculate a precise mapping. And then we have only one segment that is appearing only 9 times, which is the only missing letter, which is F. To double check, we can see that every letter should appear in this mapping only once, because the mapping is bidirectional. So A, B, C, D, E, F, G. We have everything, and this is the mapping. So we just return the mapping. Now, what we have to do is to write a function that, given the mapping that we just calculated and one of the values that is after the pipe sign in every line, tells us what is the digit corresponding to that. So we call this function the code value, and this function will receive the mapping, so the dictionary that is essentially the solution to the problem, because that's the hard part, and the value, which is just a string. This will decide what are the segments that are turned on by a specific value, the segment in the canonical representation, so the real segments that we can track, and then simply tells us what is the value corresponding to the segment, so what is the actual number corresponding to them. To do that, we go through the to the mapping and simply remap the value. So mapped is equal to a list where we have mapping of V for V in value. So value is a list of letters which represent the segment that we have in a digit, and we map them back to the original value, the one that is used in the problem description. After that, we have a sequence of letters, for example, A, B, C, E, and what we want to do is to map these segments that now are in a single unique representation for every line to the actual digit between 0 and 9. This is a trivial problem because what you have to do is simply to look at the display, at how it looks like, and write down essentially which segments are turned on for every possible digit, and vice versa. So we call these decodings. It's a dictionary. And a small problem that we have here is that we have multiple representations of the same number. So AB and BA are actually the same number. So what we do is we always take the segment letters in alphabetical order. So first of all, we have 1, and 1 is CF. So we just say that CF, segments C and F, correspond to the number 1, because that's the digit 1. Then we have 2. What is 2? I have them on a paper, it's not on the screen, but essentially you just look at the problem definition and you see them. 2 is ACDEG. So ACDEG equal to 3 is ACDFG. It's very similar. So this is 3. Then what we have the number 4, which is BCDF. CDF, which is 4. Is it correct? Yeah, seems correct. Then we have the number 5, which is ABDFG. ABDFG equals 5. 6 is ABDEFG. Is 6. 7 is of course just 3 values, which are A, C, and F. Again, I'm writing them in alphabetical order because I will have to do the representation. 8 is easy because it turns on everything, so it's just the alphabet. A, B, C, D, E, F, G is 8. And then the last one is 9, which is A, B, C, let's see, D, E, F, G. 9. Okay, so now we have the decoding, so we simply say decoded is equal to the value that we have in mapped, so the segment. No, actually is the codings of what? Of the string representation of mapped. What is mapped at the moment is a list, so we have to convert this list into a string. So instead of having a list of letters, we have actually the letters. So we just say empty string dot join mapped, which simply will join the letters with an empty string between them. So we'll reconstruct the string. Now the coded is the value that we have here, so the number. And we just return it. So we don't even assign to a variable, we just return. And now let's use it. So for part 2, we go through all the patterns. And for each one of them, we want to build the mapping corresponding to the pattern. So the mapping is equal to, what was the name of the function? Calculate mapping of the patterns. So this simply takes care of the part of the line that is before the pipe sign and reconstructs how segments are mapped. And what we want then is to get this mapping and get the value. So for v in values, we want to get the digit. So actually this is a list comprehension, so we say digits. So the 4 digits are equal to what? To the value in values, so for v in values. They are strings, and we want to invoke our decode value function by passing the mapping that we calculated, and it is the same for the whole line, and the value v. What is this? Is a list of what? Of numbers, because this dictionary is giving us numbers. This is not ideal because what I want is actually a string, so I convert it to a string. I also use the type int. I don't use them often because they take more writing in this case, but they're a good idea if you have a big project. Now digit is a list of strings, so what I do, I join. Again, same reason. We have a list of strings, but I want to create a single string. Digits is now the number, and what I want to do is to convert it to an actual number. What I do with that, I want to take the sum, so I say the total is equal to 0 before the cycle, and then here increase the total of this value, and then I return it. So let's try to run this. There is a mapping error, so one of the digits here was not found, ABDGF. So I use my paper to see what is ABDGF. ABDGF, yes, because ABDGF is not in alphabetical order, so I'm missing some sorting here. So when I decode the value, sure, the value itself is a string, but I want a sorted version of the string because I need to find it in this dictionary. So I need to essentially sort it and transform it somehow. Where is the code? So for the mapping, the mapped value is the sorted version of this thing. ABC. This time the string seems correct. This time is in alphabetical order. Let's see, A, B, C, A, F, G. This is at 0. And the 0, is not here, so I missed a digit, which is the 0. And the 0 is, in fact, this one. So I just copy this and write it as 0. So I was just forgetting the 0. And now I can run again. And I get none because I'm not returning the total, so just returning. So I know what this is the result. This should be the result. Let's see if it is correct. I copy here, I submit, and it's correct. Thank you for watching and see you for the next part. Bye!